So measurement of steam quality. So for the lecture, what is steam quality muna? Okay. Mechanical Engineering Laboratory 2. Pala sa loob. So this is the measurement niya. Okay. Pupunta sa sample lang to nung measurement. Using valve steam header, kukuha siya ng sample. Ayan, punta sa steam separator. So dito, mapapalaman mo yung kung ilan yung separate pang steam saka moisture to yung liquid. So measure mo siya, so kukuha mo na yung quality. Ilan. So what is steam quality? Steam quality is the proportion of saturated steam vapor in a saturated condensate liquid steam vapor or vapor mixture. So ito yung mixture mo. So ilan yung saturated steam or vapor, then ilan yung liquid in mass, by mass. Steam quality of 0 indicates 100% liquid. So dito siya. Ito yung saturation ko. While steam quality of 100% liquid, so dito siya, B. Condensate ang tawag dyan. So while steam quality of 100% indicates 100% steam, okay, or vapor. So 1 pound of steam with 95% steam at 5% of liquid entrainment has a steam quality of 0.95. Okay, 95 plus 5 is 100%. The temperature needed to obtain a steam quality are the measurements needed to obtain a steam quality measurement are temperature, pressure, and entrained liquid content. Okay, pag pressure, temperature, superheated yan. Okay, check nyo yan. Pag more than 100% na yung quality mo. A high percentage, 88% or more of industrial steam system use saturated steam for process application. Saturated steam, meaning steam that is saturated with energy, is completely gaseous and contains no liquid. Kaya nga saturated. The boiler operation uses chemical energy from a fuel source to deliver energy to the boiler water. Inside the boiler, liquid gains energy from the combustion process and changes state into saturated steam. Boiling. Water enters the boiler at point A, and the water gains sensible energy to point B, and the change of state is referenced as point B on the chart. So dito ang reference niya. Punta doon, mag-change of state na siya. As the saturated steam acquires more energy from the boiler combustion process, this steam achieves a high quality, moving left to right, as represented on the charts from B to C. The energy increase gained by steam from point C to D goes towards the superheat of the vapor. So yan ang definition ng steam quality. Okay? There exists a direct proportional relationship between the temperature and pressure in saturated steam. So at least pag mag-ibig ang temperature, meron ding katapat na pressure. That is, as the temperature increases, so does the pressure. Illustrated by the lines of constant pressure on the graph. Saan ba yun? So this is the line of constant pressure. So dito, nagtataas yung temperature mo, so yung constant pressure mo tumataas din. O di, wag mo paglampas niyan, so iba na ang curve nun. So, more sensible SOF is needed for water to transition from A to B and become a vapor. When steam enters the process, the energy level goes from right to left as the process absorbs energy from the steam. Okay. Pumasok sa process na. Ginamit mo na yung steam na yan. So, bababa ulit yan. Because the process absorbs the energy from the steam. Okay? Why steam quality is important? So, today's manufacturing techniques of heat transfer, control, and standards are all dedicated to improving and providing highest quality product to the marketplace. So to attain the highest quality, each manufactured component of the final product is inspected repeatedly and measured for its quality to ensure that it meets the manufacturer's and consumers' expectation. Okay. So, steam is a vital and critical part in producing the final product. Therefore, steam quality should be one of the main measurable points in producing a product in today's manufacturing facility. All heat transfer components, cell tube, plate in frame, plate in coil, tracing, etc. Ito yung mga types of heat exchangers. Common kasi yung cell and tube, di ba? Plate and frame, so yun yung mga yung LMTD niya masyado maliit. Okay? Pati yung plate and coil din, mga compact yan. Tracing is yung mga pipe sa pipe yan. Okay? Pinabalot sa pipe. Base performance calculation on 100% steam quality unless the manufacturer is informed by the end user that the steam quality is lower than 100%. Unfortunately, this steam quality is typically not monitored closely and is assumed to be 100%. Therefore, issues that arise from poor steam quality are blamed on some other item in the system. So based on field documentation, a high percentage of steam systems are operating below acceptable steam quality levels. Low steam quality affects steam system operation in many ways. A. Reduce heat transfer efficiency. So the major problem with low steam quality is the effect yan. Effect yung nakalagay. Effect on the heat transfer equipment and process. Kinopya natin effect nakalagay. In some cases, low steam quality can reduce heat transfer efficiency by more than 65%. So the liquid entrained in the steam has sensible energy, 16% estimated varies with pressure, which has a significantly lower amount of energy than the steam vapor's latent heat, 94%. Therefore, less usable energy is being delivered to steam process equipment. And check nyo yan pag nag-design kayo. Oops. Back. So also, the additional liquid low steam quality collects on the wetted surface of the heat exchanger, causing an additional buildup of a liquid which reduces the ability of the steam's latent energy to be transferred to the product. B. Premature valve failure. Liquid passing through steam control valves will erode the internal of the valves, causing premature failure. Letter C. Internal turbine components failure. So liquid introduced with the steam in a saturated turbine operation will reduce the life expectancy of the internal properties. Letter D. Water hammer. Steam systems are usually not designed to accommodate the additional liquid in steam. Additional liquid creates the chance for water hammer to occur. Water hammer is a safety issue and may cause premature failure in the steam system. Ito yung mga bad sa piping. How is steam quality measured? So, a true measurement of steam quality can be obtained by using the throttling calorimeter. Diba? So, alam niyo yan, thermo. Unfortunately, most industrial plants do not have the luxury or capability of doing the testing. Another way to measure steam quality is relying on the basics of steam. Saturated steam is a dry, invisible gas and only becomes visible when the entrained air or liquid Okay, doon makikita. Therefore, opening a steam valve and allowing steam to be released into the atmosphere provides an estimate of the steam quality in the system. Pag-release mo. So, yung kanina yung figure kanina, nirelease lang yung yung trap. So, load map to ensure a high quality steam. So, the following items will ensure a high quality steam. A. Insulate steam lines in component. Kasi mag-condense siya, di ba? So pag na-heat loss siya, so magbaba yung enthalpy value niya. B. Establish proper steam line, drip legs, steam trap station. So, sa steam piping, makikita mo doon, may distansya niya, meron siyang drip leg. Saka mga pag-change ng elevation, may drip leg. Doon siya dinidrain yung mga moisture. C. Develop proper startup procedure. D. Implement a proactive boiler chemical program. E. Implement a proactive steam system management program. F. Install steam preparators, so mechanical coalescing design if needed. Ayan. Okay. Ito sa mga high subject. Hindi natin naabot yan. Depende lang kung dyan kayo napunta. So pag-aaralan nyo yan. Diba? Yan kayo nagtrabaho. Expertise na yan. So ito yung throttling calorimeter. So separating and throttling calorimeter theory. The temperature changes of a gas or liquid when it is forced through a valve or porous plug while keep insulated so that the heat is exchanged with the environment. So this procedure is called a throttling process. Yung constant enthalpy. This procedure is called a throttling process. This effect can be described by the Joule-Thomson effect or Joule-Kelvin effect or the Kelvin-Joule effect or Joule-Thomson expansion. In the Joule experiment, the gas expands in a vacuum and the temperature drop of the system is 0 if the gas were ideal. This is a schematic diagram for the separating and throttling calorimeter. So, yan. Ito yung separating. Ano ba yung itinap mo dito? Dito. Kaya mag-separate dito yung steam. Nakatap siya. Ito dito. Tapos dyan. Tapos yung steam, liquid bababa. Yung steam nandun. I-reduce mo yung makuha mo yung value niya. Constant enthalpy. So, cooling water. So, yan. So, pressure yan. Pasok dyan. Condenser. So, kung ilan na namang moisture, ito yung measurement mo nung steam. Separating eh. Kinul mo, tapos pupunta yung steam. Yung ilang weight ito, yung weight din yung steam na kinuha mo dito. Ito naman, yung moisture dito sa actual. Ito naman converted, di ba? So in this process, oops, kanya nabasa ba? In this process, there is no change in enthalpy from state 1 to state 2. H1 is equal to H2. No work is done. W is equal to 0 and the process is adiabatic. Q is equal to 0. Let's take an advantage of throttling process is an ideal gas flow through a valve in mid position. So we can observe that Pn is equal to P out. So velocity N is equal to less than velocity out, where P is the pressure and Bl is the velocity. This observation confirmed the theory that Hn is equal to H1. Remember, H is equal to U plus PB, where B is specific volume. So if the pressure decreases, then a specific volume must increase if enthalpy is to remain constant. So assuming U is a constant. Because mass flow is constant, the change in a specific volume is observed as an increase in gas velocity. The theory also states work is equal to 0. Our observation again confirms this to be true, as clearly no work has been done by the throttling process. Finally, the theory states that an ideal throttling process is adiabatic. This cannot clearly be proven by observation since a real throttling process is not ideal and will a throttling process is not ideal and will have some heat transfer. Ito lang. Ito totoo to. Okay. Separating calorimeter. It consists of two concentric chambers, two. The inner chamber, ito, and the outer chamber, which communicate with each other to an opening at the top. Ito pa yung inner, ito yung outer, so ito yung opening sa top. As the steam discharges to the metal basket, which has large number of holes, the water particles due to their heavier movement get separated from the steam and collect in the chamber. The comparatively dry steam in the inner chamber moves up and down, edging through the annular space between the two chambers and enters the throttling calorimeter. So, yan, lipat sa doon. It is a vessel used initially to separate some of the moisture from the steam to ensure superior condition after throttling. So, dito wala na siyang Moisture. The steam is made to change direction suddenly. So the moisture droplet being heavier than vapor drop out of the suspension and are collected at the bottom of the vessel. Okay, throttling calorimeter. It consists of a narrow throat or a piece. Pressure and temperature are measured by pressure gauge and thermometer. Kasi dito sa throttle valve, magiging ano siya, superheated. So, meron siyang pressure and temperature kasi yung superheated na yun, i-cool mo yun, ba? So, the steam after throttling process passes through the heat exchanger and condensate is collected. Yeah. It is a vessel with a needle valve fitted to the inside. Then, the steam is totaled to the needle valve and exhausted to the condenser. Yeah. So, maikli lang tong na-discuss natin sa if magkaroon ng revision, medyo haba pa to. So, sa internet, marami namang discussion tong pag-compute ng quality. So, next, dryness factor. So, ito equipment na. The quality of wet steam is usually defined by its dryness fraction. When the dryness fraction, pressure, and the temperature of the steam are known, then the state of wet steam is fully defined. Okay, enthalpy. In a steam plant, it is at times necessary to know the state of the steam. For wet steam, this entails finding the dryness fraction. When the steam is very wet, we make use of separating calorimeter. Okay? So combined calorimeter. Separating calorimeter does not give an accurate result and the throttling calorimeter fails if the steam is not superheated after throttling. So kaya nga, meron dito. A combination of separating and throttling calorimeter is therefore found most suitable for accurate measurement of dryness of steam. So yan yung figure. Sample. Steam leaves an industrial boiler at 120 pounds per square inch absolute and 341.25 Fahrenheit. A portion of the steam is passed through a throttling calorimeter and is exhausted to atmosphere when the barometer is 14.7. So, hindi sa in-exhaust sa condenser, atmosphere. Yun. How much moisture does the steam leaving the boiler contain if the temperature of the steam at the calorimeter is 240 Fahrenheit? Yeah. That is the moisture content. So, given P1 is 120 PSI, P2 is 14.7 PSI, T2 is equal to 240 Fahrenheit required amount of moisture solution. So at P2 is 14.7 PSI, T2 is 240 Fahrenheit. From steam table, H2 is 1164 BTU per pound. And throttling calorimeter na to And then at P1 is 120 PSI. SF1 is equal to 312.50 BTU per pound. SG1 is equal to 1190.37. Yan. So, yung steam in-excess mo sa atmosphere. Doon na siya makakondense sa atmosphere. Diba? Then, H2 is equal to, sa total, so throttling calorimeter, constant enthalpy. So, H2 is equal to HF1 plus X times HG1 minus HF1. So, substitute values. Meron tayong 1164 is 312.58 plus X times 1190.37 minus 312.58. Or X is 0.97. This is the steam quality. Ang required natin is how much moisture. So this is Y or 1 minus X is 1 minus 0.97 or 0.03 or 3%. So this is the answer. Okay. So this is also the end of the topic. So this is the equipment. Yeah. Thank you.